Hello boys and girls, and welcome to the next video on multiplication. And today we're going to be looking at 3-digit by 2-digit multiplication. So let's start off with a warm-up question, and here it is. Take a moment to have a go at these questions, pause the video, and when you're ready, we'll go through them together. Okay, so the first question, 4 times 12 is simply 48. And if we know that 12 times 4 is 48, then hopefully we can realize that the answer to question 2 is going to be 10 times larger, because you can see here this 40 is actually 10 times larger than this 4 here. So the answer is going to be 480. Let's move on to question 3, 206 by 3. Well, if I was going to do this with a formal method, it would be 206 multiplied by 3. So let's put our line there. 6 times 3 is 18. 3 times 0 is 0. Add the 1 is 1. And 3 times 2 is 6. Now, if I know that 206 times 3 is 618, how much bigger is the 300 compared to the 3? Well, it's actually 100 times bigger. So therefore, the answer has to be 100 times larger. So it's going to be 61,800, because what we would do here is we would be adding an additional 2 zeros onto the answer like that. Okay. So today we are going to look at 3 digits multiplied by 2 digits. Let's look at this question here, 132 times 23. What we also know is that if we were to partition the 23, we could partition it by saying 132 times 3 and 132 times 20, and we'll get onto that part of the question shortly. So let's start to cross multiply. We're going to do 3 times 2 first, will give us 6. We're going to do 3 times 3 is 9. Remember that 9 is actually 90. How do we know it's 90? Well, firstly it's in the tens column, and also 3 times 3 here, remember this is 30, 3 lots of 30 is 90. And we put it straight into the tens column. And then finally, 3 times 1 is 3. Remember that 1 is 100, so it's 300. Now we move on to the next column. We're going to multiply by the 2. Remember that 2 is actually a 20. 2 times 2 is 40, not 4, because remember, this is 20. 20 times 2 is 40. Another way, if you find it easier, just simply add a 0 and then think of it as 2 times 2 is 4. But that is the operational steps you should take. But in terms of actually understanding what is going on, that explains why we have a 0 here, because really it's actually 20 we're multiplying by the 2. Let's keep going. 2 times 3 is 6, although strictly it is actually 600. And 2 times 1 is 20 times 100, which is 2,000. So now we add the numbers up. 6, 9 and 4 is 13, 6 and 3 plus 1 is 10, and 2 plus 1 is 3. So we get 3,036. Let's look at this question here. 326 times 32. Stop the video, have a go, and then come back and we'll solve it together. So 326 times 32. We're going to do 2 times 6 is 12. Now this time, the 1 that has been regrouped into the tens column has been placed there. You'll notice it's smaller than the other numbers. That's to not confuse it later on. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, and we simply put the 6. Second row, if you remember the previous question, I said you can simply put a 0 in there. There's the 0. 6 times 3 is 18. That 1 there is being exchanged and regrouped from 10 tens to 100. 3 times 2 is 6, plus the 1 will give us 7. And lastly, 3 times 3 is 9. So as you can see here, there is a very clear pattern. You start with the ones, multiply, multiply, multiply. Second row, put in a 0, multiply, 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 and that's the order. Let's add them up, and we get 10,042. Right, let's see how we can put this column multiplication formal methods into a worded problem. So there we go, we can see 3 children there, Dora, Alex and Teddy. And what they've all worked out is what they believe the answer is to 248 times 21. Now, we don't want to actually work it out exactly, but could we work out which child is closest to the answer, or who's actually got it right? But I mean, can we eliminate 2 definitely wrong answers? What do you think we could do here without actually physically working out 248 times 21? Could we eliminate the wrong answers? Well, I have an idea. We could round them up. So we could estimate by rounding up. So 248 is closest to 250, and 21 is closest to 20. So let's multiply that because it's much easier to do. The next question is, do we actually need to do a column multiplication? Do we need to do this and go through all the different steps, or is there another way? Well, think back to a week ago when we did some starter questions. Is there another way we can divide up the 20 quite nicely? Well, there actually are quite a few different ways to solve this question. One way is to think about this as, instead of 250, think of it as 25 and think of it times by 2. That's one way, but you'll notice we have a 0 and a 0 there, which we haven't put into the question here. Have you noticed this is actually 10 times smaller? And that's 10 times smaller. So if we know that 25 times 2 is 50, we really should be multiplying by 10 and multiplying by 10 again. So we need to make the number 100 times bigger to give us 5,000. Another way to solve this question would be to think of it like this. 250 times 20 is the same as 250 times 10 times 2, because 10 times 2 is the same as a 20. So what is 250 times 10? It's 2,500. What is 2,500 times 2? It's 5,000. We get the same answer. Or another way we could have done this, we could have said 250 times by 2 would give us 500, and 500 times 10 is 5,000. So there's actually quite a few different ways to solve it. And of course, we could also use our traditional column multiplication if we so wished, but I wouldn't recommend it for this type of question. Let's have a go anyway, just to check. 0 times 0 is 0, 0 times 5 is 0, 0 times 2 is 0. Second row, add a 0, 2 times 0 is 0, 2 times 5 is 10, 2 times 2 is 4, plus 1 is 5. Let's add them up. 0, 0, 0, and 5. So there's one other way to do it there, 5,000. So there's 5,000 there. We could do it this method, or we could do it this method. Lots of ways we can solve this question. So we can see that Alex was the closest. And we can see that Alex's score is the closest. Dora's is barely 3,000, and Teddy's score is way over 7,500. Obviously, Alex has got the answer that's closest to our estimation. So the answer here would be Alex. Estimate each side of this equation and write less than, more than, or equal to complete the statement. So let's think about how we use some estimation in the previous question to solve this one here. Well, again, we've got a number that is very close to, if we rounded it to the nearest 10, we get 180. And this one we could round down to 20. The answer will be 4,000, because what we've done is we've done 200 times 2 times 10. We can think of it like that. So 200 times 2 is 400. 400 times 10 is 4,000. Let's look at the other side. Let's call it 100 because it's very close to 100. And 63 is very close to 60. So again, let's think about 60 as a 6 times a 10. So 100 times 6 is 600. 600 times 10 is 6,000. So which one is smaller? Which one is bigger? Well, we always start on the left, and our statement starts with the left number. So we would say 4,000 is something 6,000. So we can see here very clearly that 4,000 is smaller than 6,000, so we're going to use a less than sign. Let's look at another worded problem. So Mo orders some muffins for his party, and he can order a box of A's or B's or C's. But he decides to order a box of A, and he's going to get 12 of those. So he's going to have 12 of those boxes. He's going to have 20 of these boxes, and he's going to have 14 of these boxes. But you can see within each box there is a certain number of muffins. In fact, you can see here there's just one muffin in there, so that's easy to work out. And here we have 2, 4, 6, 8, 10. So there's 10 muffins in each box there. And here there are 3, 6, 9, 12. There we go. So there's all the important information there for us. The question is asking us, oh dearie me, how many muffins does he order? So we're going to have to multiply all of these numbers out. So have a think about that and come back in a minute. Okay, so we have 12 times 1 is 12, which is box A, and we have 20 times 10 is going to be 200 for box B, and box C is going to be 14 times 12. Well, have you got any suggestions how you could solve that? How could we do 12 times 14? Well, one method is to do 14 times 2, and then add on to that 14 times 10. So 14 times 12 is the same as 14 times 2, and then added together is 14 times 10. How does that make sense? Well, if we go to a traditional method here, you can see that if we use our first step, which is to do 2 times 4 is 8, and then 2 times 1 is 2, we get our 28 there. Because remember, we're actually taking this 14 and we're firstly multiplying it by the 2. Now, if we multiply by the 1, remember that 1 is actually 10. So that 1 there is a 10, which is the same as this one down here. I know this can be slightly confusing, but if you feel that this doesn't make a huge amount of sense, then I would say just think about it in terms of its traditional form, and then by adding them up, you will find that you would get the answer of 168. So therefore, if we add up 12, 200 and 168, we should arrive at our answer of 380. Let's just check that here. So I'm going to do, I'm going to do 200 because it's the largest number, and I'm going to add to it 168. So I've got 168 underneath, and I can just do that in my head as 368. But then I'm going to add on to that 12, which gives me 368, 378, and 380. So I found for that question, doing the column addition method in my head was the most acceptable and most appropriate method there. The final question on this input asks us to calculate the cost that Mo spends. Well, we know that he bought 380 muffins, and we know that each muffin costs 24 pence. So let's do 380 times 24. Now let's be very careful here, because we are going to be dealing with pence, so we are going to end up with quite a large number. If we were dealing with pounds, then it would look very different. We might end up with something like this. But we don't really want to be multiplying by decimals at this stage. So we're going to keep it at 24 pence, but remember that is pence. So let's use a more formal method. 0 times 4 is 0, which is there. 4 times 8 is 32. 4 times 3 is 12. Add 3 will give us 15. Let's move on to the next row down here. We're now going to be doing 2 times 0, but don't forget the 0 needs to go into this space here. There's my 0. 2 times 0 is 0. 2 times 8 is 16. The 1 moves down to the next column. And then 2 times 3 is 6, plus the 1 gives us our 7. Now we add them up. 0, 2, 6 and 5 is 11. Now we need to be very careful here writing the right numbers. That number is now gone. 7 plus 1 plus 1 is 9. And there it is. So we have a huge answer here of 9,112 pennies. But it's a bit awkward and not very elegant to use such thousands of numbers in the thousands when we talk about pennies. We would now probably be much better to try to convert it into pounds. So how are we going to do that? Well, let's think about how this might look on a place value chart. Let's put the numbers onto the place value chart here. What we know is, how do we go from pence into pounds? We want to turn this into pounds, like that. But if we know that for every 100 pennies we get a pound, or for every £1 there is 100 pennies, to go from pence to pounds we should be divided by 1,000, which you can see here. So we need to divide by 1,000. We need to divide by 100. How do we divide by 100? Well, if we put our numbers into our place value grid, to divide by 1,000, we need to move each and every digit to the right. Because as we move numbers to the right on the place value grid, they get 10 times smaller. But we want to go 100 times smaller. So every time we move a number, it becomes 10 times smaller. And if we move it again, it becomes 10 times smaller again. But its jump from one place value column, and if we jump 2 place value columns, it's getting 100 times smaller. So that's 10 times smaller. And from there to there is 100 times smaller. So let's move the numbers one at a time, 2 places to the right. There's the first, that's the ones column. It's moved from the ones column to the tenths and then into the hundredths. The 2 has moved from the ones into the tenths column. It's jumped over the decimal point. The 1 has moved into the tens and then into the ones. And finally, the 9 has moved from the hundreds column into the tens column. And now we can confidently call this number, we can refer to this number as pounds now. So we have £91 and 20p. And there it is there. So as you can see on the screen here, this is the core activity sheet for you to have a go at. So as you can see, question 1 asks you to begin with some 2-digit by 1-digit multiplication questions, and then you build up to double digit. And then question B here, you're going from 3 digits times 1 digit, and then moving up to 3 digits times 2 digits. Keep working through question 2, looking at the way the work has been laid out. So as you can see, question 1 and question 2 are gradually building up your confidence in the questions. Question 3 is to find the mistake. And then question 4 is to use your understanding of the formal method without any support. Questions 5 and beyond are more worded problems for you to have a go at. And they do get progressively harder as you go through the worksheet. Now, if you are finding this level a good level for you, that's fantastic. But if you'd like to give yourself an extra challenge, as always, I have a variety of questions in the folder. There is some varied fluency for you to have a look at. There are some reasoning questions here, and these reasoning questions always have kind of questions for you to answer in terms of understanding why this happens or why that doesn't happen. It's a very different type of question, but equally very important. There's another reasoning question there for you to have a look at, see if you can spot the mistake. And then below here, you will find the answers. Lastly, for those children who might be finding this a bit difficult, in the folder I have put an additional PowerPoint called Support Explanation 3x2 PowerPoint. And in there are some slides for you to go through to see if they can help you and develop your understanding and support your understanding. And you can go through these, and they give a bit more information, and they explain the methodology and how things can be done step by step like this. So worth having a look at if you are feeling a bit stuck on how to proceed. So best of luck, and I look forward, as all the teachers do, to your work, and best of luck.